Oh, that radio is not available anymore, but the same one that has the same characteristics. Okay. We can agree upon these things. And maybe the design differs because I didn't get all my requirements right. It's really hard to tell you guys ahead of time, here's what I want you to build, but I can't tell you how to build it. I'm not going to tell you exactly what to use. But it needs to be, like this. It's really hard to think ahead of time of all the possible designs you may pitch to me so I can weed out the ones that I don't want. It's very hard to get that right. On the other side of the table, it's very hard to read something that we've written and really understand what we're trying to get from you. We'd like you to build a plane that does this, that, and the other, or put this in a Humvee to do this. Well, I can describe that 10 ways from Sunday, but until we have a conversation, it's really hard. So right before you pass these milestones, there's a PDR, a design review, and there's a critical design document we produce from this. PDR can happen sooner at a certain milestone, but these milestones are very rigid gateways to move from one phase to another, and you can't start cutting code until you've answered these questions first. This is really good stuff. You can complain about government bureaucracy, but this is really good stuff. Now, critical design review is the go, no-go for some of these things, and then we move on. At some point, we're done sort of developing the system, and we actually want to start testing what we've built. And there's a series of tests that we go through, like low-rate production tests or maybe a full operational test. And in there would be security-specific testing where we'd pen test it and red team it, or we'd actually scan it for vulnerabilities using system tools and things, and operations deployment. If you have a life cycle, it should have paces like that. But the neat thing is, today, compared to a year ago, we've got better tools. A year ago, if I asked anyone who's pitching a contract, and I would say this in my contract language, when you write code, I expect you to vet it for code correctness, at least. I don't know if you have logic problems, but please make sure when you write your code, you don't put buffer overflows, you don't do integer overflows. Remember that Ariane rocket? Please don't do that. Casting things right. What else is wrong? Any stack and heap problems. I'll go through a whole list. There's a whole bunch of these flaws, and there's whole categories and a taxonomy I can give. But I'm waving my hand, and what would they do? Okay, that'll cost you $1.5 million, and it'll take me 6 months to have all my guys look through all the source code. It doesn't help. I don't have that kind of time, nor do I want to spend that kind of money. And honestly, if I was on that program and it wasn't written, well, even if it wasn't written in a language I didn't understand, let's pretend I'm not a really good developer. And you know what? Maybe I'm not the right person to interpret the code review results. How do you have someone oversee that to make sure it's just not a crazy activity? It's just said, oh yeah, we looked at them, they're all good. You need someone who actually understands the code. So we have code now. We have code processing tools. We have static analysis tools. We have testing environment tools, things that we didn't have before, which came because, like all good things come, something bad happened and someone said, make sure this never happens again. And you can Google for that. And we now have tools to help the code quality, which means now I can start selecting for language. When I ask people to build stuff for me, I can start specifying the use of tools. Now you can go on the internet right now and pull down find bugs or find flaws or any of these lexical scanners, which is slightly dirty word scanners for code, basically. Hey, there's a lot of false positives. It looks like you might not be checking boundary on this statement that you're calling. And here's a bunch of lists of functions that you really shouldn't be using, and you're using them. It helps, but it's no better than grep. Now, the tools that you can use, and I wish you guys, at least at college level, had access to some of these things. Some of the enterprise level software analysis tools, we're still talking static analysis, are awesome. We actually at the Air Force have a Center of Excellence for Application Software Security, the ASACOE, Application Software Assurance Center of Excellence. Everything in the military is a Center of Excellence. Sometimes they're excellent, and these guys are. They've connected with Cigital and with the use of Fortify, SCA tool, the software code analysis. This thing's very powerful. Pull up a whole C or C++ project, and it doesn't just lexically scan the code looking for obvious, maybe code correctness problems. It can find where you're casting an integer and maybe the overflow would occur to you. But it reduces all the false positives because it takes it a step further and actually analyzes the execution path, data paths, data that is taken from external data sources and ends up at a sink without something being done with it. Well, now I have better than a manual code analysis. I can zoom in on a very specific flaw, and it will tell me what the stack looked like that it ran in its head to make it occur. Now, it's not a runtime analysis, but my gosh, that's darn close. So this loop right here, where you have 1024 bytes, and you're counting from 0 to 1023, And the very next line where you put a null at the 1024th byte, you're off by 1. You just slammed a null in as someone else's variable. Please don't do that. Wow, that's easy to fix. You took an integer and used it as an unsigned integer everywhere, and then when you compared it as a signed integer. That might be important because 65,536 is less than 10 if it's signed. So we have tools now that we can start asking to use or offering to use for our contractors. But again, remember, I can't really tell them they have to use this tool, but I can suggest here is the level at which you need to do analysis and what deliverables you need to make sure come to us during the course of development so I can be sure that you're doing the right things. And that's possible. And we can offer this tool, or you can use one commensurate. The neat thing is the software industry solving that problem I told you about before. I'm making a case. I'm telling people this code's secure. They're actually working on it. Actually, Purdue's working on it. Mitre and Purdue and a bunch of other folks, a lot of other folks, are working on this problem of making software and security, software assurance and security in general, measurable. It started years ago. Simple things like viruses and vulnerabilities in code. Instead of having one scanner software say, I find 200 flaws, and one say, I found 210, I'm better than him, they double count the same flaw. Why don't we have a taxonomy and enumeration of these things, CVE, and it changed the whole way that works. So with CWE, they have weaknesses enumerations. KPEC is something where we can actually start maybe mapping out how a weakness is exploited. Well, this is perfect for me, because one of the best things for a development crew is if someone can give you feedback. If you're developing something, and you're done with version 1, and I've used it for a year, and you're working on new features, wouldn't you like to hear from me? Hey, that was great, but I wish it did this. Or, wow, this feature's kind of funky. You might want to fix it, because it's not always the right thing. It doesn't always save the right way. This is feedback. Well, we don't often get that kind of feedback loop like we would want all the time. But in my world, there is a feedback organism, an organization. The Intel folks, they know threat data. Here's what bad guys are doing. Well, I'd like to hear that, because I'm building a thing that does this. Are any of these things targets of attack? And if they are, can you tell me something about them? The problem with that is sometimes they can't. I mean, they know it, but they can't tell you. Because if we start building things to mitigate a very, 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 very specific attack, well, then the bad guys know we know about that attack. Maybe that's not always useful. We can't always do that. So that leaves me kind of stuck. But if you could describe the attack in ways that don't give away tactics and techniques, but some measurable way of showing me how weakness is exploited, and if you could tell me what the weakness is in a way that shows me what the weakness in the code is without telling me exactly what the flaw, that the vulnerability that's exploited, that I don't want to know how to exploit. I just want to know what's the weakness in my code and how do they get to it, the pathway and the end goal. Well, with these, maybe I can start building those assurance cases. And we're not there everywhere, but at least with CWE, the publishing of the top 25 and the other ones that didn't make the top 25, the top 25 weaknesses people put in code. Oh, this is perfect. I now have a list I can point to and say, make sure you don't put any of these in your code because they're so obvious and everyone knows them and it's the top one. SQL injection should be gone by now. That's embarrassing. You don't scan your input? That's very easy in some ways. There's libraries that do input validation. Come on, move forward. All right. Oh, I jumped ahead. This is the top 25. So here's the story. There's an Air Force program working with software weaknesses, and just when we needed it, the folks at CWE shared ahead of time, before it was officially published, the top 25 list, which we could then use with our defense contractor, who met us 100% on using tools to improve the software and making sure at least the top 25, because at some point, here's the list of flaws, and here's how many we can fix. Which ones do we fix, right? We should fix the ones that remotely exploitable. Okay, that's good. Ones that definitely smash a stack, like a heap overflow might be slightly less risky than a stack overflow. And if it's not in the top 25, well, that's what we did. And right now we're exploring how do we get this better? How do we move this along another path? So we're still keeping our eyes on. This is where something like an effort of changing the context of the security problem is important. I live in a world where most people go, it's really nice that you guys are trying to a taxonomy or an ontology and I don't know the difference and why would I care? And you're trying to enumerate flaws. Okay, whatever. I've got this stuff to build and I need to make it better. You didn't tell me how your stuff is going to help me. So come back when you have a tool work